Hello, Spark fans, and welcome back to Advancing Spark, brought to you by Advancing Analytics, your friendly neighborhood data and AI consultancy. Now, I want to talk about orchestration today, my first love. Before I got into the dirty depths of Spark and distributed processing and all of that good stuff, I really cared about ETL frameworks and processing methodologies and orchestration. Now, it's with heartfelt apologies, sorry guys, we've not really used that much of Databricks Workflows in the past because they've been a bit clunky. They're very, very rigid, they're very static. So we've had to have anti-patterns where you'd say, I need to run these 10 things concurrently, so I'll have 10 different tasks, and I'll need to manually assign dependencies. And compared to how people tend to work with dynamic DAGs and all that good stuff, that just doesn't really work for modern ways of doing orchestration. So last week, we saw ForEach loops. That's it. ForEach loops and parameterization released for Databricks Workflows, and suddenly that opens up so many things that we can do. So that's the plan today. Just have a quick look at building just a tiny little metadata-driven orchestration framework using the new ForEach task type in Databricks Workflows. So that is my plan. Until we get to there, there's a bunch of things going on in September. So next week, it is the Data and AI World Tour in London. And there's just loads of stuff going on. So we're going to be there. We're going to be talking about some stuff. Come and see us on the booth and say hello. That'd be good. The week after that, it's the Big Data London, which is, again, a massive event. We'll be there. Come and say hello. It's all of the conferences in London. There's also one I want to give a shout out to. So this is the Data Engineering for AI ML, the Data Layer for AI. That is a conference coming up, again, the week after next. So it's very, very soon. And that is super interesting. That is a remote conference. Feel free to go and register for that. I'll drop a link in the description below. And there is a whole bunch of stuff. The whole idea being kind of just explaining how you build a good data foundation layer so that you can do lots of AI and MLOps and all of that good stuff. Whole host of fantastic speakers. You got Hans from DuckDB, you got Joe Rice, you got a bunch of people. You got yours truly talking about how you do medallion architecture for AI and how the different AI personas map in. So yeah, if you're around, if you're interested, do check that out. It's going to be super interesting. And finally, as always, if you're new around here, don't forget to like and subscribe, and let me know down in the comments if you've been having a play with the new Databricks Workflows, and we'll see how we go. Right, enough of that. Let's go and have a look at what is going on. So we saw this last week. Streaming repetitive tasks in Databricks Workflows. I think that understates what this actually does. I would rename this title to making Databricks Workflows actually good. A much snappier title. But it does quite well kind of show the thing that I'm talking about. This whole idea of going from this nasty, gnarly thing of having a load of hard-coded tasks into, can I just make a loop, please? And control it with some metadata. Ah, yes, that is how we do orchestration these days. So a bunch of things we can do in here. Yes, we've got ForEach loops. Some limitations in there we'll talk about. We can do dynamic parameters, we can pass things back, we can control concurrency, we can debug things. I'll show you how all that stuff works in a second. Now, the obvious question here is going, well, if you want to do like a declarative data processing, why not use Delta Live tables? And there's a bunch of reasons for that. And that Delta Live tables is great for doing a fairly known pipeline of a fairly small number of tables and saying that just runs and that is just super easy and bulletproof. Grand. DLT is great for that. If you have anything weird, like I've got two different tables and they need to insert data into the same destination table, but at different cadences, suddenly gets weird and hard with DLT because it has this concept of ownership of that table by the DLT pipeline. So mixes of cadences, having it decide to do different things partway through the loop because it got some data and went, oh, I'll process that instead. You can't really, it's not flexible enough for a lot of the ways that clients ask us to build things. So if you have a fairly rigid, fairly known thing and you're talking about 50 to 100 tables, great, use DLT. Save you a load of trouble. If you're trying to build something complex, this will actually help us build something a little bit more complex. This is for people like me doing things for enterprises who want to do things in a madly complex way. So, how does it actually work? Let's go and have a look at a few little examples. I've been playing around with a few different things. So I've kind of built this nice little one to try and get it to work. There's a few bits and pieces just I've been playing around with just to see how does this fit together. So let's have a look at this first. Let's get rid of that. I think that was just something I slapped in there as a bit of a demo. Yeah, we don't need that in the mix. Let's just, whoops. Yeah, we don't need that. That has dependency. No, there we go. Okay. So in this case, I'm going off, I've built a Databricks workflow. And I've said the first thing I want to do is have some kind of Python library that's managing my list of stuff to do. I'm storing my processing dependencies as JSON, essentially. And so I've kind of like mocked together a little bit of Python that goes and says, what should I run? Oh, this is what we're going to run. And we need to use job parameters to do that. I've then got my ForEach loop that we're going to go and use to process that. But first things first, let's go and have a look at this. So I've got a task. It's a Python script type of task. Again, you could use that as a Python wheel and pass in the functions and do it properly. I'm just slinging it straight to a script going, there's a script there that'll set the parameter for you. Nice and easy. It's in my workspace. I'm just pointing it at a given file. No drama there. So we're going to have a look at what that actually looks like. Shock horror. I've just hard-coded something. So I'm saying, okay, my dependency graph for this, it's an array. Has to be an array if we're going into a ForEach loop. Makes sense. And that's got 3 steps in there, 3 different IDs, and I've got a schema name and I've got a table name for each of them. Now, the important part, to make that visible, to make any outputs, whether this is a Python script, Python wheel, whether it's in a notebook, I need to pass that back and set it as some kind of task value. So I've got this thing, dbutils.jobs task values.set. There is also a .get, so I can grab them in the middle of my script if I need to. And I'm making up a new variable. I've not had to set that anywhere. I've not got a predefined list of these. I've just said, make something called myDAG and slap my JSON array into it. Okay, so first thing I'm doing is calling this little bit of Python to say, grab an array, slap it into there. So in the rest of my workflow, if I want to refer to my job parameters .myDAG, I can do, and that'll be populated with that array. So step 1, get an array of data. I can hard code that, sure. I mean, yeah, it might be a quick, easy way to do things of just go and have a play with my job parameters and just wang that same thing into there as an array and use that. And then when you need to change things, just edit that one array. That's easy mode, but it's kind of the same as having just lots of manual tasks. It's not that different. So go off, get some stuff, read some stuff from a JSON file, query a delta table, go and do something, pass it back, pass me back an array of data. I then got my new task. So I'm just going to create a new one to show you what that looks like. It's way down on my list. So let me just pull this up so we can see it. There we go. So you can see right down the bottom, inside my control flow things, I've got a ForEach loop. So I'm saying make a new task. It's a ForEach loop. Loop through some things, learn to type, whatever. To type a ForEach, and it needs that inputs. So that inputs, as you can see, it's expecting some kind of square bracket JSON array of things to loop over. So again, I can hard code stuff in there and type it in, or I've got this little dynamic value reference. And I can say, what are my dynamic values? Well, I've got the results of my previous task if it had some kind of output we wanted to put through, or I've got the value of that kind of thing. So I can go and say, go and have a look at this. So in terms of my things, I can poke it, point it at that stuff. I can also point to those job parameters quite nicely. So good. That works quite nicely for me. Cancel it. So in here, I'm pointing it to task.getDAG.values. Let's look at any values that's coming out as a result of that. Anything I've set into those job values, .myDAG. Again, reminder, myDAG's just a name I made up inside there. I don't know why I called it myDAG, just to make things really confusing. Going in, being set. If I then run that, I'm expecting to see 3 different runs of the internal task. So inside here, I add tasks inside of that that ForEach loop. There is a limitation here compared to some other orchestration tools. Data Factory, for example, I could have a chain of different activities happening inside of my ForEach iteration. Here, I can have a single iteration. I can have a single task. You can do one action for each of the iterations inside of your array. Feels like a limitation, but I can just call another Databricks job if I need to. That's not that bad. In this super quick little toy box, I've just called a Databricks notebook. So I've said, okay, for each thing in my notebook, go and call this particular notebook. Here's the parameter I want to do. And I've just passed input. So whatever the current row I'm on has, pass that down as my input. So actually, what I can see, my input in this case is going to be that whole JSON object. You're like, rah! There's one whole object, and I can then query that, parse it, and go, well, tell me the ID, tell me the schema name, tell me the table name. I can pull it apart if I want to. So yeah, we can work those things out. We can pull that through. If I just go and give this a quick run. Now, I've not come back and tested this since I made a more advanced version, so I might have broken this, but we'll see if it works. It's fine. I could also have just gone and shown you a previous run of it that actually worked. So yeah, while we wait for that, that's fine. So for this case, I ran the middle test, no reason. So that for each loop, again, I skipped there a little bit quickly. Inside of my workflow, I can go to previous runs. I've got my run history of all the different times I've tried to run it. I can dig into what happened on this particular run. I can see my different stats, how long each thing took, etc. The big thing is if I dig into my for each loop, I get the breakdown of what happened on each iteration. And I can see in here, I pass through the ID, the schema, the table name. It's already got the JSON context for those different parameters, but actually pulled out into different commas based on the stuff that I threw into it. I can then dig down into that and say, well, actually show me what happened. And there's my notebook. So for that run, I could see the widget I had inside my notebook, again, super quick demo notebook, was given that context. It was passed in a flattened string of here's your ID, schema name, table name, and I can again just parse that out in Python to then start using it in the rest of my notebook. So that makes sense. I can have a real simple get a list of stuff to do and then go and process it. But again, it feels a little bit limited there, right? It feels like it's not really doing that much. And there's one or two things that we need to fix in there for it to actually be good. So I took this nice, simple example. I'm processing 3 tables at once. Ah, wow, magic. And said, what about something that looks a little bit more like an actual data processing DAG? So I've got 3 layers that I'm trying to do in sequence. Each layer has a bunch of tables. So essentially, I'm just doing this 3 times. So to get into my bronze layer, I need to run this notebook with these 3 parameters. To get into my silver layer, I need to run this notebook with these 3 parameters. To get into this layer, I need to do this. So I'm kind of just pulling out, going a little bit more parameterized, a little bit more dynamic, but actually having, essentially, it's a for each loop inside a for each loop. So I need to do 3 lots of processing, but actually for each lot of processing, I've got 3 lots of processing to do. So trying to build out something that's actually processing in something as layers and going through that process. So to do that, I had to call a job within a job. So I've modularized how this is working. So I've got something just to run a notebook. So that is a give me a parameter and I'll run a notebook passing those parameters in. Easy. I've got for a given layer. So for each of my bronze, silver, and gold, give me an array and I'll put that into a for each loop and then run those notebooks in parallel. And then I've got my whole master grandfather processor that's actually doing the whole thing. So if we step through these, right at the top, I've run it once. As soon as it worked, I went, I'll make a video. Grand. So if we go in here, I've got my same thing. Go and get my list of stuff. In this case, instead of using that hard-coded thing, right, I've just used the other one that's got the full list of stuff in there. I'm calling this Python script going, get this full array that has my different layers and return that as my DAG instead. That's all it's doing differently. I've then got a for each loop. I'm stepping in and saying, run this for each of those layers. So you can see for each one, it's going through. Let's have a bit of a look at the tasks actually before we go too deep into this. So same setup, Python script doing that full orchestration. My for each loop taking the results of that, going in a loop. I only want concurrency to be 1 here. I don't want it to try and process all layers at once because I want it to do the first layer, then the second layer, then the third layer, etc. Then for my actual, to process each layer, I'm not calling a notebook. Instead, inside of that for each loop, I've got a run job. So I've got a master job that's calling child Databricks jobs, which is going to call child Databricks jobs. I can have this little hierarchy of execution context going through. All makes sense. So all I'm saying is, well, for that parameter that child job's expecting, pass in this particular thing. In this case, where the input, if we have a look at it, the input for that actual iteration is that full thing. I don't want to pass that in. I just want to pass in the array because it's a little bit tricky to pull out child values of the JSON argument for some reason in the child job. Super easy to pass it down. So in here I'm saying we'll take input dot processes, pass that array into the iteration. So iteration 1, give it all the child jobs. Iteration 2, give it the child jobs. Iteration 3, give it the child job. Just go through it that way. So then we actually step back. We have a look at how it executed. We could see, yes, it went and it ran and it got my the DAG back. My for each loop, it should have ran for those 3 layers. I can see it ran for bronze, then silver, then gold. Great, it's running them in order. And I can see that it passed in that kind of structure to the whole thing. So we can go and if we dug into that process, we'd see that's just the bronze ones. I can see that's just the gold one because there's only a single fact, etc. So that's working quite nicely. That's then calling that child job. So let's have a look at the child job. Child job, just process the layer. And that is just dirty and easy. Take the array that I've received, slap that into a for each loop, and then call a child job for each one of those I get. Again, just passing parameters down the loop, just allowing that little bit of extra iteration. Now, the reason I've done it this way, I mean, so inside of my for each loop, could I have had a for each loop? It's for the task inside my for each loop? No, technically not. So in order to have nested iterators, I need to break it up and down into jobs anyway. But also I might want to top and tail this with a little Python script doing some logging or checking some details or retrieving some extra metadata. Loads of things I could be doing to make this a little bit more fancy. This is very much a quick toy I made. But you can see we're passing that down. So for each table I have in this particular layer, I'll kick off a run notebook job and then pass it down. Again, my run notebook job is super easy. It is literally run my notebook, please. Here's the parameter. Just pass that straight in. Nothing fancy. So if we go down that chain from the top, I've got my various runs. I'll dig into my runs. I can dig down this path and go, okay, so what happened in that for each loop? Okay, I ran bronze, silver, gold. Okay, so what actually happened for bronze? Let's dig into that. Okay, we can see, oh, okay, there was a for each loop. There's only one task who's gone straight into it. It's ran 3 different things. Okay, so I've ran in bronze, sales LT products, address, and customer. Okay, well, let's go and have a look at what happened inside address. That's kicked off a child job. We can go and see that's actually run. We can dig into that job and say what happened here. There we go. So I've got the results for that particular execution, and I can dive into the notebook and say what happened here. Well, no, there wasn't the ephemeral notebook. I can dive into the relevant one for the last run. There we go. You see in this case, that was the last one in the chain. But you can see that successfully trickled down each of those things. And that is me, it took me about 20 minutes of trying a few different things again, some syntax right, to say, take this idea of, I have a process I want to run, make it use Databricks Workflows and make it dynamic. Now, historically, I use things in Azure. We use things like Data Factory for that. You could be using Airflow, you could be using Prefect. There's a bunch of different orchestrators out in the world that are going to do that management of that DAG for you. Now, the tricky piece, certainly the tricky piece with external orchestrators, if I'm using Data Factory to do this, yeah, absolutely. I can do for each loops in as a ADF pipeline. I can kick off notebooks that are parameterized. I'll have the fairly nice monitoring plane of all that. I can do all of that. We've been able to do all of that stuff for ages. The big difference of what I can do here is actually I can set my compute to be serverless. Or I can set my compute to be a job cluster and then share that job cluster. I don't have to use like an interactive cluster or lots and lots and lots and lots and lots and lots of job clusters. So actually, by clicking serverless, I've got some efficiencies here. Now, I've not had to dig into this yet. I've not had a look to see how efficiently it shares and reuses compute. If I'm kicking off 100 different notebooks and I'm saying run it all concurrently, actually, how efficiently does it do that? Does it spin up separate serverless things, but there's spare cores on each? Does it try and jam it all on the same thing? I've not really done a lot of digging yet, because again, came out officially last week to say what this actually looks like on the costing side, on the efficiency side. But certainly it should be cheaper. We can use, certainly, if you can do it using one shared job cluster across everything, that'll be cheaper than doing it via an interactive cluster via Data Factory, which is going to charge you for having the pipelines there anyway. But as long as we've got the efficiencies under there, as long as this is reusing and efficiently utilizing compute behind the scenes, as long as we're just being charged for the CPUs we actually used, great. Now, obviously, it's very early days. I've not had to dig into a lot of the error handling and the robustness and what does it look like in production? What is the extra wrappings that you need to put around each one of those child jobs in terms of the logging and controls, if you need any? But let's have a look. Let's take a peek, see if it actually works. Actually works quite nicely. It lets us do lots of stuff. I can have a nice trickle down, dynamic, orchestrated pipeline. So yeah. And that is all I really wanted to run through today, is just going, this is new, it's out there. I'll put a link down below to the new, to the announcement blog and some of the documentation behind there. Yeah, I'm kind of excited to see what people actually think about it, if people actually start using it. Are there reasons you're not using it? In which case, what kind of pitfalls have you come across? What kind of alternatives do you have that aren't costing you more money and letting you keep things just inside a single box of Databricks to stop with any extra orchestrator? So if you're using a solution that means you have to spin up a Docker container or an additional little VM somewhere or pay for another cloud native tool, that's probably not a good solution if we can get it to do with things natively, but it actually works. I don't want to compromise by adopting things that are just native to it. So if that actually allows us to do everything, it might be a really good step forward in terms of the future of how we do processing that is dynamic enough. Pretty cool. Right. That is all I wanted to run through today. As always, thanks for watching. Don't forget to like and subscribe, and I'll catch you next time. Cheers.